Good afternoon, everyone. This is Barb Tyson, and today we have former Salty Dog Sailing Association President Hank George with us, and he's going to be sharing information on planning a lithium battery bank upgrade. Hank has a background in the electric power industry and is the president of Blue Heron Battery, so I know he's got some great information to pass along today. And before we get started, those couple of reminders, as always, keep muted, keep video off, but go ahead and use that chat box to put in your questions or any comments. Hank's going to be answering questions at the end, but if you want to go ahead and put your questions in the chat box while you're thinking about them, that's always a good idea. As always, we are recording this webinar, and everyone who's registered will be emailed the link. And now I'm going to hand things over to Hank.
Well, thank you, Barb. It sounds like it's dinner time for your dog.
Yeah,
anyway, good afternoon, everyone. Thank you for taking the time to join us. And I'm going to try to keep this at a fairly high level, so it's sort of introductory. But then I can certainly answer any questions later on at the end, or you can contact me for more detail. And let's see, let's go ahead and do this. I'm going to turn off my video. Things are a little unstable at this end. Well, let's see, Barb, it looks like we've locked up on the slides. Let's see if I can do this.
Yeah, if you maybe hit start from the beginning, or sometimes there's an arrow. And if that doesn't work, you could try stop share.
Yeah,
you got it. Okay.
Yeah, I went ahead and restarted the share. So what I'd like to cover today are some several topics here. What kind of thinking goes into sizing your battery bank, choosing a location, some insurance issues that are on the forefront these days. And as part of that, what are the risks with lithium batteries? Talk a little bit about sort of, a vision that I and a number of others have outlined, what we call a lithium battery safety paradigm. And get into that a little later. And then charging, some aspects that you need to keep in mind when charging, some options that you have there. And then last, long-term care of the battery bank. And of course, after that, any questions that I can help on. So maybe first, why lithium? It's something that's really getting a lot of attention around the cruising community, has for the last 8 or 10 years. And I think in a lot of ways, lithium has arrived. It has some very reliable manufacturers and suppliers. It's a capacity issue. One interesting thing is how much added capacity you can get out of your batteries. Same size battery as, say, an AGM, and there are many more available amp hours. Plus, you're able to use them all the way down to essentially zero without damaging the battery, which we certainly can't do with our lead acid batteries. The available cycles on the lithium batteries are now up to the range of 6,000 to 8,000 cycles, as compared to AGMs typically being around 500 cycles in a lifetime of the battery. Charging rate, you're able to charge lithiums much faster, weight and size. They're smaller in size and lighter in weight, for the same amount of power. And lifetime cost now has come down considerably, to where the lifetime cost with lithium is about 1/3 to maybe even 1/5. If you did the life of a lithium battery, you would be replacing an equivalent AGM bank 3 times over or more in that lifetime of the lithium batteries. Also, some of the cost comparisons, if you look at a quality 8D, like a Lifeline, that goes for an 8D that goes for $800. Usable amp hours are in the range of 117 to 135. That's 50% of the rated. So the cost ranges on those from about 6.8, down to $5.9 per usable amp hour. And if we look at our lithium batteries that are on the market, the quality ones, they're right in there at $6.6 per amp hour. So you're starting out, if you get a good supplier and, just on the battery cost itself, it's not too much different than AGM now. But I do recognize you may need to do some hardware changes. Sometimes it's just changing settings, but sometimes you have to add external regulator on the alternator. Maybe change your battery charger because it may not line up well with what lithium battery needs. So there can be some added costs there, that are a difference, but you get the payback over the lifetime. So battery bank sizing, how do you pick something? I mean, I say that a lot of folks do is basically say if I have whatever, a current battery bank, let's say it's a 300 amp battery bank, to use something like 60% to 70% of that and say, well, then I would need to have equivalent usable amp hours plus a little bit would be to go with 180 amp or a 210 amp hour battery bank. And so you have some added usable capacity, for, things you may add in the future. So that's one way to do it on sort of a 1-for-1 basis. If your current battery bank when it was new is working out pretty well, then that could be a good way to do it. Another could be, well, maybe I'm looking at adding some things in the future. So maybe I just put in the same rating to the current rating. And let's say you have that 300 amp hour rating, put in 300 amp hours of lithium. And so it gives you, many more usable amp hours, and it allows room for growth, adding some equipment, putting in a better, maybe more powerful autopilot, whatever's on the horizon. The other way to do it is just to, if your current bank's worked out pretty well, just even it up on usable amp hours, and then outline the things you're planning to add as you do your refit of your boat and what the needs are for those. So some general guidelines that we've used with a number of folks, small sail and boats often average around a 200 amp hour lithium battery bank, mid-size sail and power 300 to 600, and large sail and power 600 to 1200. And then you can go up from there. If you're going to be adding more than the typical or average equipment, you want to have some capability to pick up air conditioning, or you have very hungry, let's say, refrigeration equipment, then you may need to bump up from these averages. So some general guidelines that you can use. So different manufacturers that are out there, how do you pick them? Well, part of it I'd suggest is staying with US companies. And in fact, insurance companies are going that way these days on the lithium batteries. They say, we want you to get something from a reputable US company. Part of it is the tech support. They're easy to get to. They're can get on the phone with you and help you through planning your project or dealing with issues you have down the road. It's very hard if you buy something that's off Amazon. It's let's just say it's some foreign company that's selling on the cheap on Amazon, and there's no real tech support that you can access to get help. And maybe that's okay with you and you want to go that way, but I think you also get into some issues about the quality of the batteries, the quality of the cells that are being used. Another consideration I'd suggest on the chemistry is to make sure you go with lithium iron phosphate or LiFePO4. Lithium iron phosphate, and there are various attributes and risks, and I'll discuss those a little later, but for sure, stay away from the lithium cobalt. There'll be a higher energy density, and there are some manufacturers out there that offer those. They're what you see quite commonly in e-bikes and the hoverboards, but they're in our cell phones and in our computers too. Applications where you need a high energy density, and you want to have a lot of capacity, but you don't want to be carrying a computer that's 10 pounds heavier than what they are now. So there are some real benefits to having that lightweight and that high energy. but you need to be careful with that chemistry, and I'll touch on that a little later. There are some choices in terms of prismatic versus cylindrical versus pouch. If you look at the picture in the upper right, you see the little cylinders. That's out of an e-bike battery, but they're similar for marine applications that weld or solder together a whole series of cylinders, and in the right arrangement in parallel and in series to give you the amp hour and voltage that's desired. And so that's the cylindrical approach. If you look to the bottom right, which happens to be a Victron battery with a cap off, you can see the prismatic cells that are in there, prismatic being sort of a rectangular shape. And those are then clamped together. The circuit board that's there in this case is a cell balancing circuit board and cell monitoring. And then there's an external part of the BMS, in this case, that handles some safety features in terms of, turning on alarms, turning off the battery or shutting down charging. So that's a prismatic, and that also shows in the bottom middle picture. And then there are the pouch type, and I don't have a picture here of that. It does show up in another slide. And they're somewhat like the prismatic, but they don't have a rigid container on the outside. And most often the pouch are the lithium cobalt or lithium manganese, and probably not the best for our applications for a house bank. A number of lithium start batteries are being made with those. They can discharge power very quickly. And so they'll function very well that way. But we'll talk about start batteries a little later as well. So, there are decisions across those. What do you want? The better deep cycle batteries are prismatic. You can do many more cycles. They'll have a little longer life. They don't mind the deep cycle, deep discharge, and a very rapid recharge. Cylindrical, you have to charge just a little slower to make sure you're not overheating, and they don't end up with as long a life, but they're still good batteries. I don't want to diminish them. Comparison, I think for our applications, my recommendation is to go the prismatic direction. And maybe just as a reference, that's who Victron uses, Mastervolt uses, we do, and one or two others. So drop-in versus modular. The drop-in term is like the battery that's in the lower left. It's made out of lithium cells, lithium iron phosphate cells, but the shape of the outer box for the battery is the same size as a standard. It's UCI designation on size of batteries that we're used to in the US and pretty much in the marine industry. So the one that's there is very similar to an 8D in size. And if that's all you have as far as space, then that kind of a battery makes sense to drop in. Or if it's an area that may have some moisture or whatever else, you don't want any of these to be standing in water, but if there could be some moisture spray, a little more humidity, that kind of a battery is sealed up with the BMS internal. And so it's better for that application. If you have a little more flexibility on where to place the battery and the room, and you have a little taller space than say the low profile of an 8D or a group 27 or a group 31 or a 4D, those are most generally sort of a lower profile, 8 to 9 inches tall. If you have a little more room, like under a settee seat, under a berth, where you've got, say, 12 or 13 inches, something like the modular that's in the middle will fit in there. And the one that's shown is a 210 amp hour battery. And you can put 2 to 3 of those in the place of where an 8D is and end up with 600 amp hours. But a current 8D is 210 usable, 210 to 230, usable of 100, 105, 120. So, it's very space efficient, and you can gain a locker with something like that as well. So selecting where to put it is what we lead into here. The logical starting place is look at your current battery locker or battery box and start there and see what space or dimensions you have available, and then I can size something to go in there. But like I said, if you have a little more height, then the modular work well. If it's going to go down in a bilge like the middle picture here at the bottom, then a drop-in battery will be the better application. The lower left is a modular that's going into a locker. The top right and lower right are battery boxes that are specialty made for or intended for batteries, and you'd be able to find the right size lithium battery to go into that existing space. That's sort of the nice thing with the drop-in in terms of being made to a standard battery size, and can fit it into the space where an existing battery is. The top middle is a battery box. Sometimes you can get, you have space and you want a full box to protect the battery for whatever various reasons, or maybe it's already there. That's an 8D box. And, two of the modular 410s would fit in there, interestingly enough. So it's a tall enough, even though it's 4 and 8D, it's a tall enough box that can fit. So, the existing battery locker may be a starting point. Some of you may have issues with, well, there was very little battery capacity on the boat to begin with, and you want more physical space than that. And so, look under the bunks, the settee seating tend to be good areas that people find. I think you want to avoid an engine room, avoid cockpit lockers if you can. Below the cabin sole, can work if you're pretty confident that you've got a deep bilge, so that water is not going to be an issue. The other is the batteries need to be tied down well. In the lower right, you can see some straps across the top of the battery. You want them to really be locked in very tightly. That center picture with just the lightweight straps, probably a little weak. I think, heavier duty straps could work, but some sort of a tie down, with a bar or a couple of bars like are shown over to the right would be good. Chocking at the bottom so the batteries can't slide around. You clamp it down, it's tight and they can't go anywhere. And you just don't want the batteries moving around, banging into things and doing damage to the battery. So one question that I get a lot is concerning the start battery and the bow thruster batteries. Am I going to need to replace those? Can I just do the house bank? And the answer is yes. And not only yes, you can get by with it, but yes, that's the better approach anyway. Lithium batteries can receive and discharge a large amount of power. But for the safety features that are built into the battery in the BMS will have some limits on how much current it can pass. And generally that limit is, it's not high enough to help start a battery. So you end up having to get a battery that has in it that can handle, 600, 800, 1,000 cold cranking amps, just so you can have a starting battery. So it ends up, in my view, being sort of, counter to what's sort of naturally available with the batteries. And AGM is very good for discharging a high amount of power. And we can set up ways to where, your starting battery can just stay on its own. The bow thruster can stay on its own, get the right charge profile that it needs. And then lithium can get the charge profile it needs. One example of that would be if you have a large alternator and you go ahead and align that to your house battery, but with a 3-stage regulator, so you can set the programming for the desired charge profile for lithium. Then you can use something like what's on the lower right here. This is a DC to DC charger. It's not just a DC to DC converter. Its output has settings that can be adjusted to match any charge profile that you want. So it's small, but it acts just like a battery charger. This particular one is a 15 amp, but you can get 18 and 30 amp, and then you can put any number of them in parallel if you want. But if all we're doing is now wanting to back charge the starting battery or starting AGM from the house bank, then one of these that's a 15 amp will probably be just fine. And you set the settings on this to match what the AGM needs. And then your regular battery charger is set to the house bank with settings that Lithium needs. The same with your alternator. An alternative, if you don't want to go to that expense of replacing the alternator with one that can accept an external regulator and then the expense of the external regulator, just let that alternator feed your start battery directly. And then you do the reverse of what I described. You use one of these smart DC to DC chargers to charge the house bank from the battery start bank, or the start battery. And it can be intertied with a switch to the ignition switch so that it only does that when the engine's running. And so you're not drawing down the start battery at other times by the house bank, and the house bank will pull down. So there are a lot of options that you can work through here. Use the right battery for the right application, and use some relatively inexpensive charging devices. This Orion TR Smart in the non-isolated version here, that's 15 amp, goes for like $210, $220. So, it's not outrageous. So insurance. Insurance companies are coming up the learning curve on things with lithium. They see a lot in the news, and a number of them say, well, lithium batteries are just high risk. Well, part of the problem is that they're confusing what they see with the things like the hoverboards, cell phones having to be turned off on airplanes because of battery fires, computers that burst into flames. If you look over at the right column, there's a long list there of lithium ion type batteries. Most of those are rechargeable, some are not. Some are the non-rechargeable type, and they're used till they're bad and they're thrown out. And, we may have those in our watches or things of that nature. Lithium iron phosphates is the first one on the list there. And that's the one that, I guess by association with other lithium, is getting questions by people. But I think some things are coming down the road where there's a little better information out there, better standards that'll help the insurance companies. And there are a number of companies that are saying, well, no, that's not a problem. We understand that, those batteries are okay. So I think we're going through a little bit of that learning process right now. The ABYC is making good progress on their lithium ion TE13 standard. And they're hoping to get that out here very soon, or this summer, to be out for public comment. But a number of insurance companies are already pointing toward it and saying, well, we want you to, do your install in accordance with that. They may throw some other things in there about we want an ABYC certified tech to do your installation, or to at least to inspect your installation. Then you do those things, and then then they provide the coverage for you. But so there are a few hoops, but then there are others that don't even raise the question or have an issue. So TE13, what does it include? It has some design safety standards in it, safe operating limits, installation guidelines, and recommended BMS parameters that they would like to see monitored by all the BMS. Try to have some consistency there. So I'm hopeful that standard gets issued before the end of the year. But one of the things that we're starting to hear, we've been contacted by a couple of the insurance companies who want just some of the background on us and what we offer and why, what testing was done, what criteria, safety criteria we had the cells certified to. Things of that nature. So that's kind of encouraging that they're asking those kind of questions, which are the right questions, I think. And by the way, Morgan Wells, who is with Jack Martin and Associates, and Jack Martin is a sponsor of the Salty Dogs. They have been for many years. He continues to say, hey, tell the Salty Dogs, anyone who has a problem finding insurance or questions being asked, to get in touch with him, and he's glad to help. So some of the lithium risks, like I had said, not all are the same. So there's a group that are non-rechargeable, they're one-time use and then you dispose of them. I guess the caution there is, these generally don't have much in the way of hazards because you're not trying to charge them. Then those set of problems that can occur during charging, don't exist. But if there's a short circuit on those, if you short them, so be careful where you put the spares for, ones that are disposable, one-time use. And we use them in our dive computer, wrist type dive computers, range finders that, we use on the boat, but you can use on a golf course. Those have the disposable type. So they will burst into flames if you short them. They are not happy. They've got a lot of energy and it releases very quickly. And you don't throw them in a fire either. I mean, kids are doing that with these disposable and people are getting hurt. So, those are ones that are generally pretty safe from their use, but just some cautions there. There are two primary types of lithium rechargeables. There are the lithium cobalt and lithium manganese are pretty common out there for, like I mentioned earlier, that high energy density. And they're called just sort of generally, they're in the class of lithium ion. And so that lithium ion term gets used even a little more broadly at times. And like all of the lithium batteries get thrown into that. It's not quite correct. But in any case, those are ones that are very high energy density. So they're great for those kind of applications, but they are highly combustible and they can self-ignite. And that's due to the chemistry. The oxygen is not very stable in their chemistry. So when they are overheated, now you have a high heat source, an ignition source, and you have oxygen. And so you have all the three components for fire. And if it's a rapid oxidation, could be an explosion. So you can go online and you can find pictures of someone overcharging a pouch cell that is a lithium cobalt, and it looks like a fireworks going off. And so, they are ones that have to be treated very, very carefully. And like I said before, if you come across anywhere someone is offering to sell them to you to put in in a boat battery bank, just don't do it. It would be half the size. They would roughly be half the size of the lithium iron phosphate batteries, and so a lot of power in a small package. But you just don't want to fool with that on a boat. Lithium iron phosphate is very stable. The cells do not self-ignite. The electrolyte is combustible, but it's much lower combustibility than what's in the high density type batteries. It has 4 constituents, 2 of which are combustible and the other 2 are not. And so it sort of dilutes it a bit, but still you have to be careful. You don't want to break them, crack them, cause a release. So you treat them carefully. And but the standards are very well advanced on these, so that like the one that's in the picture here with the plastic casing, because of the UL standards, the thickness of that plastic casing is now 3 times as large, 3 times as thick as what that same battery was 10 years ago. So it's an advancement with the standards that's really helped and it's made the batteries much safer and much more stable. And I guess it didn't touch on excellent deep cycle performance for the lithium iron phosphate and a very long life. Like I said, some that are in the 5,000 to 6,000 cycles rating, and others in the 8,000 to 9,000 cycles. And depending how you use the battery, this is really not a risk issue, but maybe just an information issue. The cycle rating is based on standard procedure and test in a set environment, set temperature. So you take your battery out into warmer temperatures or much colder temperatures. You won't get that exact cycle number. It'll be a little less or some number less. But it gives you a relative measure of some of the different batteries. And even if you were very, very careful, extremely careful, and you don't push the battery to the full charge a lot or to the full discharge a lot, and you do all the right things to maintain it, And then something else can catch you, and that is the basically it's just the a life length of this chemistry, to where the electrolyte ends up separating out a bit, and lithium ends up getting more embedded into the cathode. And so the general feeling, the FAA guideline on it for ones that are used on airplanes is just to replace them at 10 years. The expectation is there's something like an 11 to 12 to 13 year natural life that no matter how carefully or little you use it. So you could not use it, just leave it, stored per recommendations. And, and that, would, come and get the, the demise, I guess you'd say, of the battery, but that's still a pretty long period. And I think there are a lot of examples out there right now, boats that are, getting their batteries, the LiFePO4 batteries out to that kind of a lifetime. And I guess just in terms of putting things in perspective, while lithium does have risks, I think there's some good safety features and procedures that can be followed. But there are also other risks, fire risks aboard a boat, combustible material like propane, diesel, gasoline, lubricating oils. And don't forget all that resin that's in our fiberglass. It is combustible too, and a boat fire is not a pretty picture when that gets involved. So we in general just need to be careful aboard boats. There are a lot of things there that can be a fire hazard, and we need to be careful with all of these. So the safety paradigm that we've that I mentioned earlier is basically a concept of a defense in depth. That there are a lot of things that can be done to minimize the potential for having a problem with the lithium batteries, and maybe no one of them is perfect in itself, but all of them combined do provide a very robust safety program. So it sort of starts with quality cells and batteries. Don't just go buy the cheapest that's out there. Make sure it's from a qualified supplier, reputable company. I think the U.S. companies, who knows why? It's because their insurance companies require it. Because of liability, I think tend to be a little more open and honest on some of the risks and things people need to do, and helpful. And I think that's why some of the insurance companies are saying, just buy from a U.S. company. And lithium iron phosphate, as I mentioned earlier. So that's sort of, at the first level, getting quality cells and batteries being installed or installed by a qualified technician is a very positive step, and we'd highly recommend it, whether or not insurance calls for it. You want the batteries installed to the manufacturer's recommendations and to the ABYC standards. Even if you're doing it yourself, pay attention to those. Just be very careful, pay attention to them, and you treat the batteries well, they'll treat you well. Make sure you have quality charging devices. I mean, we know the name brands of, Victron and Mastervolt and Xantrex. And I guess I'd encourage you to go that direction as opposed to, ABC charging at half the price, whatever. You could fill in the blank of, these pseudo names that you see all the time popping up. And I just, be cautious of that. Charging devices are a very critical element relative to the safety of lithium. You want the charging to stop at certain points. You want it to be slowed down at certain points. And so quality charging devices can do that, and they can do it reliably. They're built to very high standards. We highly recommend that on those quality charging devices, you also program in alarms to indicate when you're approaching a high voltage level, so that alarm goes off well before the BMS has to take action and shut down charging or whatever. I go in and look at those. I think, in practice, I found very few people are even aware of that or pay attention to it, but you can go into settings. It's not going to be accessible through your dip switches. You need to get into the the software app that allows you to get into the real details and nitty gritty of your charging device, and then just go change the settings to give you this kind of, an alarm. Let's say the BMS is going to shut down charging when voltage gets above 15.5, set an alarm at 14.9. And the recommended max charge is probably something like 14.4, 14.2. I mean, our recommendation for our batteries is 14.4. And some manufacturers do a 14.6. So, you've got a hierarchy there that, you can take advantage of and get some early warning that, hey, we're on the boat, we're doing certain things, and whoops, something's going wrong here. A charger is misbehaving. And the charger shouldn't go that high, but, we're talking about defense in depth. What if the charger does start, going a little haywire here? At least give you some early warning of it. And then, quality battery monitoring devices, monitor amp hours, amps, voltage, get used to looking at that and what's normal, so that you then realize when something's not normal. It's another level of defense in the safety paradigm. The battery monitoring system. And I think too many people just say, well, I have a BM that takes care of everything. Well, I mean, it can, but it's just better to try to avoid challenging the BMS all the time, because maybe there's that one time where it doesn't respond. So, take all the good steps that you should, and but also make sure that the BMS is a quality device. You get your battery from a quality manufacturer, then they've done the legwork of testing and retesting, making sure it has good heat sinks, making sure it's got marine style connectors on it, make sure that it's got epoxy conformal coating to protect it from anything in the marine environment. So there are, a lot of features in there that, go to having a sound battery monitoring system. And then the other that I'd recommend is replacing the cells when you're getting toward end of life. Most of the issues with any of the lithium battery types tend to come a little later in life, unless it's an overcharging, which could occur any time. But once to where, as you get toward end of life, the internal resistance starts to grow a little bit. The operating temperatures start to increase a little bit on the battery cells, so a little more than they did when they were younger. And so our recommendation is when capacity gets down to 30 to 40% of the original rating, it's time to go ahead and replace the batteries. Just, go ahead and take them out. Don't risk it, pushing them until they're dead, and you can't get anything out of them. Because when they're close to that and you're trying to charge them, that's when you can get into some trouble. So the BMS I touched on a little bit. And so it monitors a lot of things, the charging voltage, and it monitors it against various set points on the high end of charging, the end of charging, and the same with discharge. There's sort of maximum discharge rates and recommended discharge rates. So the BMS can be monitoring that. If it's one that has Bluetooth, which is really a nice feature, then you can be reading all of that, all of those, data points. You can see what the temperature is within the BMS itself and the temperature within the cells. And so the BMS may monitor those and then trip off, but it's still, if you can, get the BMS that has Bluetooth, would, highly recommend that. And then the better BMSs will have charge and discharge switches, and these are digital switches built into the BMS. It's a very, very interesting logic. I think a lot of people in the industry are having a hard time understanding this, because I continue to see papers where they're saying, well, you have to do this or do that, in case charging stops. Well, the better BMSs have basically, you could call it an input tube and an output tube. It's not really a tube. It's electrical, conductor, but it has heavy duty, large scale diodes, so that it can, on that one circuit, it can allow power into the battery, and on the other, it can allow power out of the battery. So if you're overcharging, it just shuts down the charging tube, but you still got power. You've got 12 volts to everything, whether it's to your alternator or to, other stuff in the battery bank and whatever. And so or critical components. So you still have power available. And I'm not going to get into, well, okay, you need to be careful with that too, which is true, that you do need to try to monitor that and have some other controls to make sure that, okay, you stop the charging, is that going to hurt my alternator? But, there are other features that are built in to help on that. We can cover that another time. So charging considerations here, I just mentioned alternators. So earlier I had said you could use the alternator to feed your house bank directly, and you would need an external regulator for that, something like the Valmar over here to the right. Wake Speed makes an excellent one as well. Or you could have the alternator feed the start battery and just use the alternator with the internal regulator settings that it has. And then you don't have to get into that expense of the external regulator. And you use a DC charger to charge your house bank. I mentioned that before as well. The lower left is another one. This is a little heavier duty one, heavier duty than the one I showed you earlier. This is a 30 amp one, and you could have 2 or 3, unlimited number of those in parallel if you needed that for charging the house bank. So charger settings are critical with lithium. You need to set to what lithium takes, which will be a little lower bulk charge than what AGM would take, but a higher one than wet cells would use. And so a charger that worked on wet cells might not work well for AGMs or lithium. What we suggest is try to find if your charger allows you to program in your own settings, and then use the settings that the battery manufacturer gave you to use for their lithium. On some of the newer ones, they'll have a lithium setting, but don't take that as an automatic free pass and you just hit that. It may be based on some earlier knowledge that or thinking that said lithium should be charged all the way up to 14.8 and then a float of, 13.9. Well, we now find that that's not so good for the long-term life of the battery. It gets it charged very quickly when you do that, or quicker. But in the end, you keep doing that and you're actually taking away some life of the battery. And so, it's just going to the lithium setting itself may not be the best. And so a qualified installer will know how to set and adjust things so that it matches the manufacturer's recommendations. The little graph at the bottom is for those who like graphs and pictures, that it's showing sort of a charge curve that the slope's coming up and then you hit fully charge and it levels off. If you compared it to lead acid, it would be a very gradual slope that would then hit fully charged out at maybe 2/3 the way across the graph. So it takes a lot longer to get to that fully charged with an AGM or a wet cell. You get there a lot faster with lithium. And the curve, the IC, that's showing the current. So the current is a steady current until the battery is fully charged, and then it tapers off to hold it at a constant voltage. At that point, out at the bottom of that lower curve is where it's now fully charged. So let's see, let's move on. So solar controllers are another one that you need to pay attention to, because they also can overcharge your battery if they're set to too high a float charge, for example, or a bulk charge, can overcharge your lithium. And so you need to adjust the settings on them. Most of those can, but some of the early ones are not able to. So long term, what do you do to take care of the lithium battery? What's the care and maintenance? One of the things is you need to shift thinking from AGMs and wet cells, where you always keep looking at what's the battery voltage, what's my voltage? And well, with lithium, it doesn't quite work that way, because it has such a flat curve from whether you're 90% charged all the way down to only 10% charged. It's a pretty flat curve. And so looking at voltage, you're having to look at it out into the hundredths of a volt to try to figure out what it means. And then you got to remember what that means. And also when you're taking a load on the battery, then the voltage shifts. And so it's not meaningful. So you want to learn to look at amp hours or state of charge. This Bluetooth app that's over to the right, that it's a little hard to read here, but it's that lower arc in green that's in the circle is a percentage. That's the state of charge. And so it has sort of a sliding scale right there, is showing that it's 100% charged and there are 0 amps flowing into the battery. Now, if you really looked at this a little closer, you look at the little cells at the bottom, and the cells are only showing halfway across. So this is actually, it's an illustration of what info can show, but this is not an actual reading of a battery. Take it with a grain of salt. If it were reading the actual battery that was fully charged, those scales would be all the way to the right. And the reason is this hasn't yet been set up. This app wasn't yet set up for the actual battery to identify what the full charge, rating is, what the amp hour, the full amp hours are. One of the things to pay attention to is the 9-10 rule. If you can operate between 90% fully charged and down to only 10% charged, and you can keep your lithium bank within that range, you'll get a longer life. But then if you're going to do a passage, maybe go ahead and charge to 100% or whatever. You've got a need coming up to where you want that percent charge, but don't do that every day. You also don't want to discharge to 0% and say, well, the BMS will take care of me. It'll shut me down when I go too low, and then I'll turn chargers on. It's not good for that. I already mentioned earlier about, you're challenging the BMS, don't keep doing that. But also the issue is, that if you just operate in that lower 10%, or if you keep operating in the upper 10%, you take away some of the life of the battery. You'll start, at some point, maybe it's 10% or 20% that you've lost because you've just cycled in that, upper 10 or lower 10%. There are cautions on cold conditions, you keep your batteries inside cabin. We cruise in warmer climates with our boats. Generally, it tends not to be an issue. It's more of an issue with RVs, and so a lot of the batteries that are sold into the RV market that are going to be traveling in colder climes will have a thermal blanket. But you can buy, if you decide you're going to do that with your boat and go to colder climes, the lithium will be fine, and you can have you get a small little blanket pouch that the battery goes in. And storage, drop down to that. You want to store at between 50% and 70% state of charge. Just leave it at that. You can charge it to 70%, leave the battery. You only lose a couple of percent per month of a self-discharge. So the batteries will stay a long time. But if there are some onboard systems that may be monitoring, just little voltmeters and whatever else, then you will come down a little over time, and so you probably want to go check on the boat once a month or something like that, just to make sure it's doing fine, or charge it to 70% and then just disconnect it completely, and you're fine. Cold temperatures over the winter are not a problem. I mean, these batteries will withstand all the way down to 20 and 30 below without any damage, but that's Fahrenheit, below freezing or below 0 in Fahrenheit. But the issue is if you try to charge them at those low temperatures, it can cause some damage to the battery, and so that's why the bullet above, don't charge in cold conditions. But in storage, what you could do, if it's going to be long-term, you're going to be the boat's sitting for a year, have someone go check it every few months, and then maybe at least once during the year, have them put some loads on, pull it down to say 20%, and then charge it back up to 70%, and then turn everything off and disconnect the battery. It's just a little cycling that stirs up the electrolyte. So with that, I thank you for your time and attention, and I'm going to switch over to the chat here and see what questions we have.
Can you see them all right, Hank, or would you like me to read them to you?
I can see it. Thank you, Barb.
Okay.
Just opening the box a little larger here for me. So let's see. Don't U.S. battery manufacturers have to use Chinese cells? Yes, they are Chinese cells. There are some that are coming out of Japan and Korea now as well. But yeah, she used Chinese cells. But there are at least half the companies in China now all get their cells UL listed and tested to that. They also meet ISO 9000 on quality standards. And what's amazing is if you went into a factory that's an ISO 9000 factory, it's modern, clean, bright walls, high-tech equipment. But then there are others that are, dark and dank and, rows of people with soldering irons. And so that's what you have to differentiate between. And the better manufacturers will do that and make sure that, you've got all those qualifications on the cells. I guess one other little caution, what happens with that kind of a market is that there are a lot of cells that get sold over something that's called AliExpress. And AliExpress can be any individual that has like 10 or more cells. And so they'll buy discarded cells, used cells, ones that may have been in streetlights or in buses, and they'll sell them. At least generally, what I find is that because things are pretty strictly enforced over there, they won't identify those as Class A cells. They may not openly say they're Class B, which is what they are, and they may not say that they're used. But when you ask, are they used? You'll get a very short message back, yes, and nothing more. And so, you move on. And so, but I think in general, is to stay away from that AliExpress. There's no really great deal there. You'll find some cheap prices, but it's a buyer beware. Yeah. What about the windlass? It's really the same thing. I mean, you could use the windlass attached to the lithium house bank. There's no problem with that. It would have plenty of power to power it. Often what we're concerned about with the windlass is you want to have that battery bank very close to the windlass and not have a long wire. Because you want to have all the amps available, and you don't want to lose any in the resistance in the line. And that's often why there's a windlass battery close to the windlass, but then a very heavy cable going back to the house bank so that it supplements it and also keeps it charged. And that's fine to do with the windlass. However, you do need to be careful with the cranking amps issue I was referring to earlier. If you have a large battery bank that the BMS is, let's say it's 120 amp BMS on each battery, and you've got 4 batteries, or even better, 150 amp, and you've got 4 batteries, then you've got 600 amps, that's going to handle your windlass fine. Electric motors draw a lot. They'll have a higher starting amperage, but then then they'll settle down to a steady state. If all you have is a 200 amp, this is the total rating of your. If you have 200 amp hour batteries, and then you have, let's say, 100 amp BMS on that, and so you have 2 batteries, 200 amps. That's probably not going to be enough to drive that windlass. The BMS might trip off. And so just a bit of a caution there. But on the other hand, if you did an AGM battery up near the windlass, then you could, do one of those DC to DC chargers that would, charge it, in between its use. How do you dispose of LiFePO batteries? So there are a number of startup companies that are growing. It's going to be pretty straightforward shortly. Recyclers of America will come to our place and pick up, used LiFePO batteries once we accumulate up to 100. So it's not worth their while, but they're paying us for the batteries. So I think more and more we're going to be seeing places like that. Interstate Batteries says they're going to be accepting lithium batteries. They're just not ready yet because of their disposal contract is not yet in place. But there are companies that are opening. There's one in Florida that's I think will be operational next year. Another one in Georgia. That's their business plan, is to take those to extract the electrolyte and to extract the lithium. They've got processes to extract it and use it and sell back to battery manufacturers. Question, because you don't want to overcharge LifePo 4, I understand you don't want to leave the boat for periods of time with solar charging. That's exactly right. How long can they sit without recharging? So on your first point, I did touch on that a little bit about the, you don't want to overcharge it. So you do want to make sure the controller will pull back to the number we use, and I think most of the manufacturers use, is a 13.5 volts as a float charge. These LifePo batteries rest voltage is 13.8. So with a float of 13.5, the float never comes on. But if the battery slowly self-discharges, and most of the, the quality batteries will self-discharge at around 1 to 2% per month. Some of the other lithium batteries that maybe aren't as good a quality will discharge a little higher than that, like a 3 or 4% per month. So once that voltage drops down, then the solar charger, drops down below the 13.5. The solar charger would kick on. So I think it's fine to, have those settings on your solar charger and just to leave the solar charger on. It'll be fine with that. What I would suggest is, let's say you're aboard the boat for 6 months and you're in the Caribbean, and so it's going to be, up there all the time. Since you're aboard and you can manage the situation, I think just go ahead and turn, once the batteries are charged, or once they're like 90 to 95%, I would turn off the solar charger, because now we're talking about, you're just operating in that upper 10%. And that will over time take some life off the battery. It's not like an AGM where we worry about you do the deep discharges and all of a sudden you've taken a year off or 2 years off the battery or whatever. It'll be, a much smaller effect, but cumulatively, if I can get my batteries to last 10 years, I'd like to try to do that instead of, I'll keep them charged all the time and maybe they only last 8 years. Now, maybe you only plan to keep the boat 2 years, so that's fine. And you don't want to fool with it. So, that's a decision you can make, a value decision you can make. Another solar charging question is, does the 90-10 rule mean you don't want your solar panel constantly topping up? That's correct. You can, but it is the life issue I was just referring to. Strengths and weaknesses of internal versus external BMS. Good question. In internal BMS, and some call it an integrated BMS, but an internal BMS will be protected from the environment a little better. External BMS will have better heat rejection. It's not confined to rejecting the heat within the space of the box. It can reject heat to the nearby space. And that'll help on the life of the BMS. Quality BMSs are designed to exceed the life of the battery, and so they'll stand up for a long time. But still, it's a circuit board with a lot of electronics in it, and so an external then gives you that other advantage of if you were to to lose a BMS go bad. Then you're able to access it and remove it, get a new one and replace it pretty easily. It can be done with an internal, but most of the battery manufacturers would require that you ship the battery back to them, and then they would open up the case and replace it. And I think, pretty soon you're getting into sort of the value of, or the cost of a replacement battery. The other advantage, a number of the external BMSs have communications capability to where they can communicate through CAN bus or similar. And so there's then an ability to directly communicate with other electronics on the boat, a CAN bus network that could be like a Victron Direct or a Master Volt, master bus network. It also can interface with that external communications with a alternator regulator that is set up to take communications like the Wake Speed 500, and so you're able to have that communication, maybe have it give an early alert or something like that to we're getting a low voltage, in an alarm that maybe shows up on your chart plotter or whatever, as opposed to just an audible. So you can get some benefits. That communication capability isn't fully developed across most of the batteries, but on a lot of a number of suppliers are getting there to where you have that capability. Let's see, my bow thruster runs off my house AGMs currently. It is 7 horsepower, has a huge inrush current draw. I intend to have a 600 amp hour LFP. The 600 amp hours is not the issue. The 600 amp hours, the LifeBow batteries would love that, but then you got to look at the manufacturer's spec, and manufacturer's spec on each of the batteries. Let's say your 600 amp hour is 3 200 amp hour batteries. You need to look at the manufacturer's spec on that amp hour battery and what is the maximum discharge rate. So it's not the LifeBow battery, but the BMS. The BMS will have a limit. That limit maybe only be 100 amps, and that's probably not going to be enough to take care of what you're looking at there. Now you can do a few things to improve the situation. I mean, you can get a battery that has a higher rating, like 150 amps per battery times 3 batteries. That's starting to get into the range of what you need. But I think even then it would probably be just a little shy, but you can get a device that's called a soft start. And what it does is it moderates that inrush current. It's something I offhand can't think of it. If you want to get in touch with me afterwards, I see you're saying 6 times 100 amp hour. So take a look at what the rating is on the maximum discharge. It may show a momentary discharge of something like 600 amps for 3 seconds, and that'll help you for that large inrush. And then you do that across 6 batteries, it would probably take care of you. So the BMSs are made to have a limit of, let's say, 100 amps, 120 amps, 150 amps per BMS per battery. But that's a continuous discharge. So you look at that continuous because that's what you need to run the 7 horsepower. But then also look at the the inrush. The inrush, I think you can get around because they put a time delay into these BMSs so that they don't trip for about the first 2 seconds or so. They give you a little bit of time, and it's exactly for that inrush current issue and starting. Even if it's just water pumps for your water system, right? It's that any of those have issues. And so it's trying to be available to take care of that inrush. And I was starting to say, so if you want to get some information on that, the soft start, you could send me an email, and I can dig that up for you. It's a neat little device that is being used on boats for air conditioning compressors and that sort of thing for exactly that issue of the inrush current. Let's see, only feasible location in our boat is our cavernous engine compartment in a catamaran. Is it feasible to place LifeBow with a box constructed with thermostatic control, ventilation, fan, and duct? I'd say yes. I think that's a good step to go that way. I think the fans you want to go with are going to be, as well as thermostat switches. You can find online. I mean, those are used for a lot of electronics stuff these days with, very efficient, low power draw, like computer fans, but something a little larger, say 5-inch. You can find them in there, and those are very good pieces of equipment. It would also probably make sense to make sure that that your batteries have the Bluetooth option, and then you can be sitting in the cockpit and look at the Bluetooth and see what it says on look at the Bluetooth and see what it's saying in terms of internal temperatures, and so you can monitor it that way instead of just relying on the the BMS to trip. You get some early information on what's going on there. I mean, alternatively, you can put a sensor in there to a meter, to a monitor, that's always possible. We have supported some installations on some trawlers. With the large engine that's there, you think there's going to be a large amount of heat, but it actually is drawing so much air. It's bringing in a lot of air, and then has insulated the exhaust elbow and that sort of thing. So the heat sources end up tending to be fairly moderate. And what we've seen in those with the temperature monitoring is just the room temperature only going up to like 105 degrees or something like that on a hot summer day. So it's pretty impressive there. And I suspect you could manage the same thing in the catamaran compartment, particularly one where you're controlling airflow to draw out any heat. So a question, what happens next after a BMS trips off? When does it come back on? Usually each of the settings have a reset time. For example, if it's sensing a short, it waits something like 15 seconds or so before it tries it again to see if it's cleared, and then it goes a little longer and a little longer. So there's a little intelligence built into it depending what the trip is. If it was a high charging, went to a high voltage, then it's really tied into the voltage dropping back below a certain set point. And the manufacturer should be able to give you those settings, but sometimes they don't give you the full set. But usually the reset on something like that on high voltage or low voltage is waiting for voltage to come back at, if the low voltage was say a low voltage trip and turn off at 10.5 or 11.0 volts, it may wait for it to come back a half a volt higher before it switches things back on. So it varies. I know I didn't give you a single answer, but each parameter differs a little bit. If it usually takes something like a very high temperature, very low temperature, with you trying to charge, in that case, it stops the charging. But if it's a high voltage or a low voltage, those are sort of extreme set points. That's why I suggest, having alarms that are ahead of those set points so you get an early warning. But if you do get to it, in the low voltage, high voltage, it's waiting for voltage to restore itself before it turns it back on. It's, the high voltage is you're getting up to a level to where you could be doing some damage to the battery. And so it normally that'll settle back down because the rest pretty quickly, because if you've turned off a charger, because the rest voltage is 13.8, so it gets all the way up to that 15.5 and trips off. If the information you have, like if you had a Bluetooth, it would say it was a high voltage trip, and it'd be right on the front screen. And so you'd go check out your voltage, your charging equipment, and turn off whatever the offending party is. How much ventilation and cooling do LiFePO batteries need? Do all battery boxes need forced ventilation? I would say, well, no, they do not need forced ventilation, and the batteries do not generate much heat. When there's a concern with excess heat, but that tends to really be due to external factors driving the temperature up. Charging, when you're doing heavy charging of the batteries or heavy discharge, their temperature will go up. But if they were, say, at rest, say, suppose they were sitting at, say, 80 degrees Fahrenheit, and you do a heavy charge, it might drive them up to 88 or something like that. And so it's not extreme. As the batteries get older, you get into that last, 10 and 20% of their life, they have higher internal resistance. And then they start to get a little warmer, like you feel on a lead acid battery or an AGM battery, just the normal temperature. You put your hand on it when it's charging, and it feels, fairly warm, over 100 degrees. And that's what starts happening with the LiFePO batteries. When they're later in life, you'll start to notice that, which is another indication that, hey, these guys are getting a little old. Maybe it's time that we replace them. In one of the pictures, you could see plates on the end of the batteries that were clamping those cells on the LiFePO battery. And that's also because of late in life, it may start to swell a little bit. And just to protect the integrity, then, we put those plates on it to clamp it. And so if you're disposing of the battery when it's down to its, last 30% of capacity, it doesn't have any more amp hours than that, then you're probably not quite getting into that swelling period. But if you go beyond that, then you'll start to see some little swelling at the sides or whatever. And that also is another indication that, it's time to replace them. Any other questions? Thank you, guys. Good questions, by the way. Yeah, you're getting into the meat of the issue here. The concerns, but it is manageable. Okay, Barb, I think we're there.
All right, great. Thank you, Hank, for presenting this great Salty Dog webinar today. We really appreciate it. Great info. And I hope to see everyone back again on Tuesday. We'll have Josh McLean of David Walter Yachts, and he'll be discussing the current yacht sales market. And with that, I'm going to turn off the recording, and everyone have a good evening.